Welcome everyone. This is Zahid Bashir. I am a PhD scholar at Halle College of Commerce, University of Punjab, and a faculty member at Department of Commerce, University of Gujarat. Today is 29th training day. This session was basically planned for Friday previous week, but due to the weather condition, it was not held in that day. And today we are going to cover this session today. Uh, Previously, we have covered more than 85% of the contents, and therefore, today's session is very important. Today, we are going to discuss about EFA or exploratory factor analysis, which is 13th on the content list. So, what is EFA and why it is important to consider for your data analysis? So EFA or exploratory factor analysis is the process which can be carried out in SPSS to validate scales of items. So whenever you are going to develop a questionnaire, you need to validate the scale items of that questionnaire. It means you are not adopting a questionnaire from the other study. Rather, you are basically developing a questionnaire for your study for the first time, and the scales are new, and you need to validate your scales of items. So in that case, you are going to use exploratory factor analysis. The purpose of an EFA, which means exploratory factor analysis, is to describe a multi-dimensional data set using fewer variables. So once a questionnaire has been validated, another process which is called confirmatory factor analysis can be used. So as a first step, when you are going to validate scales of item from a questionnaire, as a first step, you are going to use the exploratory factor analysis. And once your scales are validated using EFA, then you are going to use CFA, which is known as confirmatory factor analysis, as a second step. So whenever you are going to use scales from another study, it means you are adopting scales from another study, you need to use confirmatory factor analysis because in that case, the EFA was conducted by that researcher. But whenever you are developing a new questionnaire with new items, in that case, you need to consider EFA as a first step and then CFA as a second step. So this is supported by Amos, a sister package to SPSS, or more easily using Smart PLS. So CFA you can conduct with Amos or Smart PLS. In case of EFA, you can use SPSS simply. So there are two forms of EFA known as factor analysis and principal component analysis. So these are the two categories of EFA. The reduced dimension produced by factor analysis are known as factors, whereas those produced by PSA are known as components. So in case of PSA, you are going to produce components, and in case of FA, you are going to produce some factors. So these are the two concepts which are being discussed in EFA. So PSA will always work, but FA may not converge to a solution. FA and PCA. So FA means factor analysis, analyzes the relationship between individual item variances and common variances shared between items, whereas PCA analysis analyzes the relationship between the individual item variance and total variance shared between items. So that is the difference. Whenever you are comparing the individual items and their common variances, you are dealing with factor analysis. And when you are uh, analyzing the individual item variances with their total variances, it means you are dealing with principal component analysis. So that is the basic difference between them. So in case of factor analysis, is therefore preferable to principal component analysis in the early stages of an analysis, as it allows use to measure the ratio of an item's unique variance to its shear variance, known as its commonality. So these are some technical terms that you will understand when I start the procedure using SPSS. For now, you need to just understand the theoretical perspective of these concepts. So, as a dimension reduction technique seeks to identify item with a shared variance, it is advisable to remove any item with a commonality score less than zero point 0.2, according to Child 2006. So, this is some reference that we are going to use with this process, that we need to remove I was discussing that when we will start the EFA process directly from SPSS, you will understand these guidelines and these procedure, because these are the procedure which are required in case whenever you need to run an EFA. So let me explain this from here. So I was discussing that the item with commonality score less than zero point 0.2 should be removed. This is the process that we will follow in EFA process. So there are two EFA methods. If you are only dealing with your sample for further analysis, for example, it is population in terms of the EFA, it is advisable to use principal axis factoring method. This is basically the most common method that we use as a part of EFA. So otherwise, if you are trying to develop an instrument to be used with other data sets in the future, it is advisable to use sample-based EFA methods such as maximum likelihood or Kaiser alpha factoring. So whenever you are trying to develop a questionnaire, this is the method that we normally use, maximum likelihood and Kaiser alpha factoring. So this is the method that we will use for our EFA analysis or exploratory factor analysis. Factor rotation method is simply a method whether to rotate the factor, and type of rotation used also need to be decided, because this method requires you uh, uh, in EFA process. So an orthogonal rotation can improve the solution from unrotated one, but it forces the factor to be independent of each other. So whenever you are using some independent factor, it means that the factor you are using should not be highly correlated. Then you should use orthogonal rotation. So the most popular orthogonal rotation technique is Varimax. So this is the method that we will use when our factors are not highly correlated. The second technique for factor rotation method is oblique rotation. It allows a degree of correlation between the factors. So whenever there is a correlation between the factors that you are using for EFA, then you are going to use oblique rotation. So this is the simple, basically the concept. So there are some important guidelines that you need to follow for EFA. According to Field 2013, 692 page, it is recommended to suppress factor loading less than zero point 0.3. So they have advised that you need to remove a factor having a loading less than zero point 0.3. Any item with all score suppressed should be removed. Scores greater than zero point 0.4 are considered stable. So this is the guideline that we will follow for EFA using SPSS. Item should not cross load too highly between factors. It means that the ratio of loading being greater than 75%, there should be as many factor as possible with that at least three non-cross loading items with an acceptable loading score. So there should be at least three item factors in each case. So item should be removed one by one until the solution satisfy all the requirement. So we will follow this guideline. The number of extracted factor may not to be reduced during the process. So this is the procedure that we will follow. Now this is the validation process that we will also follow. We will read now this validation process and we will apply the procedure. After the EFA has been carried out, there is a validation process. There are different ways to extract and double check the derived scales. For a successful analysis, there should be a higher average correlation between the items in the derived scales than the average correlation between the scales. The proportion of the total variance explained by the retained factor should be noted. As a general rule, this should be at least 50%. This is very important guideline that we will apply on our EFA, that there should be at least 50% total variance in order to retain a factor. The adequacy of the sample size should be checked. The average commonality should be checked for small sample. Finally, a test for multicollinearity based on the size of the determinant of the correlation matrix should be carried out. So these are some of the important guidelines that we are going to conduct. Now, this is the step-by-step process of conducting EFA. First of all, we will read this process and then we will apply using SPSS. The step one is before carrying out an EFA, the value of the bivariate correlation matrix of all items should be analyzed. It is easier to do this in Excel. So first of all, you need to conduct a bivariate correlation of all the items that you are going to use. High value are an indication of multicollinearity, although they are not necessarily conditioned. The second thing is field 2013 suggests removing one of a pair of item with bivariate correlation score greater than 0.80. So if you notice some correlation greater than 0.80, then you need to remove some of your items. There is no statistical mean for deciding which item of a pair to remove. This should be based on a qualitative interpretation. So you need to decide which item to remove and which item to remain retain. The second step is decide on the appropriate method and rotation. Because I have discussed that there are two methods of rotation uh, uh, that we are going to use, varimax rotation and oblique rotation. If your items are not correlated, then you are going to use varimax rotation. And if they are highly correlated, then you are going to use oblique rotation. So that is basically the important thing that you need to consider. Then you need to remove any item with commonality score less than 0.2, and then you rerun the procedure. Then step four, optimize the number of factor. The default number in SPSS is given by Kaiser's criterion, eigenvalue greater than 1, which often tend to be too high. You are looking for as many factor as possible with at least 3 items with a loading greater than 0.4 and low cross loading. Fix the number of factor to extract and rerun. Then step number 5 is remove any item with no factor loading greater than 0.3 and rerun. Step number 6, remove any item with cross loading greater than 75%, starting with the one with the lowest absolute maximum loading on all factors and rerun. Step number 7, once the solution has stabilized, check the average within and between factor correlation. To obtain the factor, use a principal component analysis with the identified item and save the regression scores. If there is not an acceptable difference between the within and between factors average correlation, try oblique rotation instead. So this is the procedure that we are going to apply. So there is step number 8 also. Provided the average within factor correlation is now higher than the average between factor correlation, a number of final checks should be made. Point A, check that the proportion of the total variance explained by the retained factor is at least 50%. Check the adequacy of the sample size using KMO statistic. A minimum acceptable score for this test is 0.5. If the sample size is less than 300, check the average commonality of the retained item, and average value of above 0.6 is acceptable for sample less than 100. So this is very important. If your sample size is less than 100, you need to consider 0.6 as a average value. If your sample size is between 100 to 200, then your average value should be between 0.5 to 0.6. The determinant of the correlation matrix should be greater than 0. Uh, tetra 01. A lower score might indicate that group of three or more questions have high intercorrelation. So, threshold for item removal should be reduced until this condition is satisfied. The Cronbach alpha coefficient for each scale can also be calculated. So these are some other considerations that we need to apply. So the last step is, if the goal of the analysis is to create scales of unique item, then the meaning of the group of unique item which load on each factor should be interpreted to give each factor a meaningful name. So this is the final step of EFA, that you need to finalize the name of the group of items, group of unique items, in order to make them meaningful. So let us start an example procedure. आयशा, ये जरा ओपन करना।